Hi, I'm Bob Doyle, the information philosopher, webcasting from my ITV studio in Cambridge, Massachusetts. And you see today's lecture title up on the screen, The Cosmic Creation Process in 3 stages, from the creation of matter to the creation of life and the creation of the human mind. And let's see if we can get here. So it's a Monday, and I've been working to improve the sound in our lab, in my studio. Several people commented that I was getting a lot of noise on the lectures, and I hope that's been corrected. I hope you'll write to me if you think it's better. I also hope you'll write to me in general. I'd love to hear from you directly. My email is bobdoyle@informationphilosopher.com. But I also appreciate your comments on my blog, on my YouTube videos, and on my Facebook videos, although I apologize that I have not been able to get responses to everyone. Some people are writing almost every day, sometimes multiple emails, which are a bit too much to me for me to really understand deeply and prepare a decent response. Some of you I have written to, and I hope to write to more of you who are trying to get to understand what I'm doing. Many people are sending me notes about what they believe is true of the things I'm working on, and I don't really understand some of them because they're quite complicated and often come from sources that are either sounding very sophisticated and scientific, almost beyond me, or they are just references to other sort of cultures, and why I'm not talking about them. My goal with these lectures, so you understand, I know this is lecture 41, so I've put up a full semester of 3 lectures a week for 13 weeks, and I hope to continue at this pace indefinitely. And you must understand that where these lectures come from is work I've been doing for the past 20 years intensely, and for the past 50, even 60 years of study as I've gone along in my career, from being a scientist to getting into more entrepreneurial things, being an inventor, and being a software developer, writing the first desktop publishing program that I could lay out my own books and get them printed out as wonderful books without any publishing company. Or I've had very little success, I must admit, in getting my articles, my kind of journal articles. I've written quite a few and submitted them to journals, but I'm taken to be an outsider. My academic qualifications at the moment, I have a PhD from Harvard, and I'm still at Harvard as a faculty appointment, but I don't teach classes, and I don't have any professorship, even a research fellowship. Perhaps I should apply for one, and I've been thinking about doing that, so I have a more formal connection. Right now I just get called an associate in the Department of Astronomy, which is my faculty position. And I get that by reason of the fact that I got my PhD at Harvard in astronomy department with a thesis on astrophysics and quantum mechanics back in 1968. Since that time, I have been struggling to understand things in cosmology, things in quantum physics, things in the philosophical implications of subjects like thermodynamics, the creation of information in the universe, the creation of in what I call information structures today, and what I used to describe as the answer to the question, how can the universe be so far away from thermal equilibrium? Let me knock off my email there. Because when I came to Harvard in 1958, the standard theory of the universe was that it had begun in a state of equilibrium, and that's also known as a state of maximum disorder or maximum entropy. The entropy is the technical term for the closeness of a system, typically a small chemical universe where they can measure the entropy exactly, And when everything has come to equilibrium, there are some important characteristics. It doesn't change after that point any of its macroscopic parameters. Its temperature doesn't change if you keep it thermal connectivity with a heat bath, so-called, and it doesn't change its entropy anymore once it gets to a maximum. And that's to say, if you went in and looked at all of the gas particles, or liquid, but gas was the typical model back from the 19th century and Ludwig Boltzmann, the distribution of all of the velocities for all of the particles has a completely random distribution, like the binomial distribution, like the random distribution of any outcomes of trials where all of the conditions are the same and basically the probabilities are the same. So when I talked to other astronomers in those days and asked how could it have gotten away from equilibrium if it started in equilibrium, and how can we be having this conversation we were having back in those days? Since then, I'm basically following an argument by a colleague at the Department of Astronomy, who was also my wife's thesis advisor, David Laser, and he had argued that the conditions of the universe, while it started in low maximum entropy for that time, it was actually a very low entropy compared to the one we have today. And how could the entropy go up beyond the maximum it was at that day? And the answer is that the universe has expanded. And the expansion of the universe basically provides more possible locations in what's called phase space. Possible locations in ordinary space, but also possible velocities in the phase space is a combination of the space of momenta or velocities and the space of ordinary coordinate space. So that's been, to me, a rather satisfactory answer, and I've been promoting it, and we'll talk a lot more about it in this lecture. So let's actually go there. Let's look at the blog post for today, which is somewhere like right here. On my blog each day I prepare the title of the talk, which you just saw on the opening of the show, and that's also where this show will appear once it goes onto my list of all my lectures. Let me just show you that for a moment. Right here. This is a page that shows the lectures we've done so far. And what I'd like to do is expand that a bit. Some of the illustrations are missing because of my this web browser. Somehow it doesn't necessarily load all. You see it loads some and not others. But at this point in time, and some of you have been with me since the point in time back in November 20th when we started, we've had about 41 lectures today. Let me enlarge it a bit more so you can see what the work looks like, and slide that over. And in principle, you can click on any of these and bring up the YouTube video. Here's January 15th today, and here's the lecture titled Cosmic Creation Process in 3 Stages: Matter, Life, and Mind. Now, if you go up to the top of this one, which is our standard page on lectures, I just want to point out that somewhere up on the left-hand side of this page, there is a little tricolor spheres, which I've been putting on my website for 15 or more years. And those 3 spheres have a lot of symbolism for me as a big technology person in video and film and color television and so forth. Those are basically the tricolor red, green, and blue dots that are in every television set. When you're looking at your screen, if you're looking on a computer or on a television set today, a typical flat display, digital display, consists of red, green, and blue pixels. picture elements. And so they are meant to me to represent the three levels I'm going to talk to you about today. Let me bring that one to full screen right here. Let me expand it a little bit more. Other way, other way, other way. So you see these three dots are representative. What I'm thinking is that green seems like a very nice notion about the material universe. And basically it's the universe, laws of physics governing everything. Things are built like galaxies, stars, and planets, and our own planet Earth, and this is like green as the Earth. I like that one. Now red seems like a beautiful representative of living things, sort of a blood red. We've got that, and the blue is symbolically representing ideas, the mind, pure abstract information, which is what the information philosopher is all about. So I don't know if anyone's ever noticed that I designed that, but that's what lies behind it. So let's come back to our blog post today. And let me talk to you a little bit about what I hope to explain. And let me remind you that all of my work, every lecture, is typically taken from something on my website, my web pages, or more specifically something out of one of my books. And in this case, let's see, I can take a look down at this book, because Great Problems is Monday, and what we're doing today is talking about the cosmic creation process. Now, this is a basically very brief introduction to cosmic creation. And I think here I've actually put my question. I like to say that the fundamental question of all of information philosophy and information physics and whatever is cosmological. And ultimately, I see it as profoundly metaphysical, because it's about the most basic question we can ask in terms of, at least in terms of information. What are the processes that create emergent information structures in the universe? Okay. Let me come back here for just a moment. Emergence is a key word, because the fact that the early universe was maximum disorder, and indeed the first 3 minutes, that wonderful book by Steven Weinberg, if you crank back to the tiniest fraction, like a trillionth of a second or nanoseconds and below, we hardly have anything that's stable yet. There are a bunch of electrons, a bunch of photons, and there are quarks, but nothing has assembled itself together, because if anything tried to get together, okay, imagine in the early universe there's this super energy everywhere, and if some structure tried to form what I call an information structure, because we recognize it as, say, an electron and a proton becoming an atom. Seems like a simple little thing, but to me, I analyze it in terms of its information content as something that is beyond the disorder, the total randomness associated with lack of information, okay? Many other great thinkers have agreed with me that entropy is sort of a lack of information. When you get to maximum entropy, everything's smoothed out, and we've got random distribution of velocities and so forth, and perfectly random distribution of positions, so nowhere has a much higher density than anywhere else except for that fluctuations that are allowed in a fully random situation. That has no information in it, okay? Well, you could say, if you look from the outside, it has a temperature, and in those early days, the universe had a temperature, which is extraordinarily high, and it had some sort of average density of the matter component when matter was there, and those are information, but they're gross macroscopic information quantities, and they don't allow us to see anything that's distinctly interesting inside this totally random distribution. And so moderns have identified the idea of low entropy with at least the potential, if not the actual realization of information. And it was usually called negative entropy. The first 20 years of my work, 30 years I think, I always referred to the question, how could there be these pockets of negative entropy? Locally, the entropy seems to have gone down from its maximum. And we'll see when we step through these paragraphs that the only way the entropy can go down in one locality is if it has succeeded in radiating away from that interesting spot inside the universe where maybe it's about to become a star or something like that. It must radiate away from that location, that object, that pocket of low entropy or negative entropy, must radiate away enough entropy to satisfy the absolute law, a principle, that the entropy of any system must always increase. It cannot overall globally decrease. Ludwig Boltzmann worried about whether there was some possibility of doing that, and there have been lots of talks about, well, what if the universe turns around when it goes, if we could make time go the other way, maybe the entropy or that disorder would decrease and we'd start to see the reemergence of order. And that's been a thought for a lot of philosophers, especially scientists who are mathematical physicists. They like the idea that if you turn the equations around and get time to go the other way, then entropy will go down. It's not at all obvious that that's the case, but that's another very technical question in cosmology. So what we need to just keep in our minds is that maximum, as entropy goes up, information is lost unless some process, which I tend to call the cosmic creation process, because stars are being created, galaxies are being created. Right at the very get-go, atoms got created, and as quickly as 380,000 years after the beginning of the universe. So things are being created. And I am going to give you what I hope is evidence of the creation of the material universe. That's what we're going to try to talk about today. And then beyond that, we'll talk about the creation or the origin and evolution of life. And then beyond that, I will try to talk about the creation and or the beginnings of information of the most abstract kind, the kind that we're talking about right now, the ideas that human beings have created and then defended as knowledge, whether you're arguing deeply philosophically about how we can actually know that we know things or how we can observe and therefore see the physical things in the world. Those are deep arguments. I'm very happy to go into them with you, and I've done so on my website. I've done so in my books. But for today, we're going to talk about these three notions, okay? We're going to talk about the first stage in which we create matter, and that's my little green ball on my website. I'm not sure if I have it here. There it is. And then we're going to talk about life, which is the little red ball up here. And then we'll go on to talk about the mind, because it's the human mind that creates purely abstract information. And that's, I symbolize with this sort of blue upper level. We can imagine them as higher and lower levels. So, you know, humanity is kind of in the middle with 1 foot on the ground, one foot on the ground, and another set of ideas that are in his mind that are kind of floating up to the skies. All right. I basically am going to trace the creation of information structures in the universe from the appearance of those elementary particles in the first few minutes, and even up to 380,000 years, we have nothing but elementary particles, and the first atoms don't appear until 380,000 years. But then we'll go through to the creation and evolution of galaxies, stars, and planets that began 400 million years after the origin. Quite amazing. The temperature had fallen when the first atoms had formed. They had fallen to about 5,000 degrees when the first atoms formed. It was like the temperature of the surface of the sun, and the same light was seen in all directions around us in the universe. Now the universe continued to cool down and cool down and cool down, and for the next few 100 million years, it just got cooler and cooler, darker and darker. That light surface of all the photons that were suddenly able to fly anywhere in the universe after this 380,000, 400,000 year time frame. We see them today when we look out at the cosmic microwave background. It's nice and uniform in all directions. We're looking at the moment in the universe when photons could start to travel through space because the atoms had combined the electrons, before which time those electrons were scattering light, making a haze in all directions, so you couldn't see anything to any great distance. Just like now on the surface of the sun, if you try to look into the sun, you can't see past the surface of the sun because there matter is ionized and electrons are scattering photons in all directions. We can only detect the interior of the sun theoretically because we can't see in more than to this surface that's in the 5,000 degree neighborhood. Okay, so all these cosmological information structures, by which I mean the galaxies, the stars, and the planets, are what I call passive structures. That is to say, they're completely controlled by fundamental physical forces. Those forces are, at the beginning, the forces that created neutrons and protons, are what we normally think of as the nuclear material from quarks and so forth. And then the electrodynamic forces that bind the electron to the proton and make an atom. Those were rather the most important forces for the first hundreds of thousands of years. And then, again, for the first few 100 million years, the temperature cools of this background. That background of light in all directions, which we still see today, is down around below 3 degrees Kelvin, almost absolute zero of temperature. But in the meantime, going from 5,000 degrees down to a few degrees, there was a long time, few 100 million years, in which there was no light, no visible light in the universe. It was quite dark, a kind of a dark age. And then gravity, which is the other force controlling and creating matter arrangements, which are interesting, and so I call them information structures, like the galaxies and the stars. They were pulled together by gravity, and when you pull them together by gravity, they heat up. It's quite interesting because the universe begins very hot, then it cools down to a temperature where we couldn't possibly live. And then, as gravity pulls large amounts of matter together, stars form, many stars, and they are sometimes arranged by a gigantic galaxy. There are other objects like clusters of stars, which are parts of galaxies, or some of them live on their own in between the galaxies. So a lot happened, but when we get to around 400 million years, it gets very interesting. I think I have a picture which I wish I had the slide for this, but for the moment, let's just look inside this book, turn the page on this, and see if I can zoom in on this picture. This is on my website somewhere, and I perhaps will be able to find it for you. Here I'm talking at the top about the 380,000 years, and if you look closely in here, I think that's described as an afterglow light pattern at 380,000 years. It's the last time in which light is coming from all directions at that temperature. And then it gets here, right, it's called here a dark age. And then at 400 or so million years, the first stars, about 400 million years. And then stars form and galaxies form. And these galaxies are all separating from one another because the universe is expanding. It's the expansion that's cooling it down. And it's the expansion that has now made room, literally made room in space for wonderful information structures. But all of those information structures, the galaxies, the stars, the planets, everything we have today, were formed by forces. They had nothing to do with what, they were not in charge of themselves. There was nothing like a galactic cosmological self until something happens with the origin of life. Okay? Let me come back for a moment, since we're in the book, and just say this question, which I asked, what are the processes? We know, and I'm trying to stress, that once we know the second law of thermodynamics, which says that any system will over time approach thermodynamic equilibrium or maximum disorder or entropy, in which all information is lost, and given the best current model for the origin of the universe, which says everything began in a state of thermodynamic equilibrium some 13.75 billion years ago, how can it be that living beings are creating and communicating vast amounts of new information every day? Why aren't we back in that original state of equilibrium? And I basically argue that there are only a few things that can produce local reductions in the entropy, reduce the entropy locally. One is gravitation. Another is quantum cooperative phenomena that cause atoms to form and crystals to form from many atoms and molecules. And then this notion of a nonlinear thermodynamics, which can somehow dissipate, and then life itself. So let's come back, continue. So I say here the fundamental physical forces like gravitation, electromagnetism, and the nuclear strong and weak force. And the major point I need to get across is that all of these galaxies, all stars, planets, cosmological objects out there that have been formed passively by these forces, there is no information per se, no idea behind I'm about to become a star, no information processing, no algorithms, no nothing that lead to these objects. These objects are created by forces, by physical forces. But then something happens when we get to the next stage. Let's see if I can find this on another page here. How about this one? Right. Let me switch to my HM. And just now I've got an ability to single out a paragraph and talk to you about it by singling out this phrase that says, with the emergence of life. So we've had the emergence of material objects up here. They're very interesting. They have emerged. But now we have the emergence of life. And with the emergence of life, relatively soon after the formation of the sun, active information structures appeared. Now, what do I mean by active information structures? Basically, I define them as structures that use information processing and communication to manage the flow of matter and energy through themselves. And I'm going to argue that active information structures introduced agency into the universe and the appearance of purpose in the universe. And let's see if I'm getting the right thing up there. Yes, I am. So active information structures introduced agency and purpose. And what do I mean? Living things generally require some biological or proto-biological mechanism of some kind by which an interesting structure, an arrangement of things to make, say, a molecule or a very long molecule, somehow figured out how to copy itself. So we have something material coming in and lining itself up with the pre-existing interesting chain of information. Think about the simplest notion of DNA as being a sequence of nucleotides. Now, we don't even have nucleotides in the early universe. We perhaps only had, but we may have. I mean, given the argument of it's not DNA, but it's RNA, or maybe all it is proteins was the original argument, and somehow they figured out a way to duplicate themselves. For my purposes, I need not go now into the biology of it, but to just argue that something has to make possible the duplication or replication of new molecules of the same kind. And once they replicate themselves, you can see that information is increasing in the universe. And once again, it can't happen unless the binding energy of all of this is radiated away, which takes away the positive entropy that second law wants to be satisfied. leaving behind, so increasing the global entropy but decreasing the local entropy. And you and I are locally reduced entropy structures, which is to say negative entropy, which is to say high information. We have a lot of information in us. And that information that we have is from the bottom at the tiniest level of our inside our cells, the little mechanisms in the cells that generate the energy molecules that go around our body, the ATP, and the little machine that builds new proteins from signals coming out of the DNA. Those are the kind of information managers I'm describing. I wish I had a kind of more powerful word that tells you what it is. It's some kinds of things that are able to use information to move matter and energy around to get a job done. I cite them here, and so let's go back up to this screen and say, from the tiny molecular machines that are the active components of our cells, and I basically am going to be, over the coming lectures, teaching you exactly how these work with little animations. The ATP synthase, the thing that synthesizes our ATP, which is our fundamental energy carrier, the little ion pumps that push ions in and out across the barrier, the cell wall of our neurons, and those motions of ions from one side to the other are the activation signals that go up and down our neurons. When we are talking to one another, let's see, I go here, those ions going in and out of along a neuron, that's us thinking, is the neuron moving ions 1, 2, 3 at a time across the surface of the neuron, so as to create an electric potential between the inside and the outside, which occasionally fires, and that's when we've been talking about Donald Hebb's argument about neurons that are firing together, they wire together. It's that firing that's happening at the level of individual ions. This is quite astonishing. The flagella is the little tail, the bacteria, mobile bacteria, wiggle a little tail to move around. That's a marvelous molecular machine we'll discuss. The ribosomes and chaperones, which do a quality check on the new proteins. If they don't fold correctly, the chaperone helps to fold them. These are wonderful information managing processes, and I want to tell you they line up perfectly with the notion of the cosmic creation process, because in each and every case of them, in order to do their work and to keep doing their work, each of these little machines needs a flow of negative entropy. That flow comes, in the case of organisms like ourselves, from food that we eat. That food grows on the surface of the earth as plants, which can directly photosynthesize the photons, which are very low entropy photons in respect to the fact that they're very hot, 5,000 degrees, the kind of color temperature of bright light, like the surface of the sun. But by the time they've come to us from the sun and reached the earth, the energy density they have is very low, more like 300 degrees Kelvin, or the temperature of the earth. And the hot sun source and the cool planet source and the night sky, which is down at the enormously cold, allow us to basically run a thermodynamic engine, like a steam engine. Whenever you have hot and you have cold, you're able to run an engine. We are that engine. The whole of the biosphere is running on a flow of negative entropy through our cells, which our little information managers can use to rearrange all the particles and rebuild new parts of us as our little parts die. I stress very often that much of us is dying. The cells are dying at every instant. Hundreds of millions of red blood cells, billions, trillions during the course of this lecture need to be replaced in my body. And they are replaced because they have the information. They know how to replace themselves using a process, an information processing that controls the flows of matter and energy through our body. So I'm going to say, or to repeat, that there's an evolutionary development that depended at every stage inside the body or all the way back to the beginning of the universe on quantum physics as the generator of new possibilities, because without possibilities we can't have new information and new actualities. And then the thing I've been stressing, the second step, is radiation away from that new information structure of excess positive entropy, without which the new information, the negative entropy, could not survive. So let me stress the picture of a little object that's trying to form in the universe. And it's in a kind of a heat bath. And if it forms and it's still too hot around it, the attempt to get rid of the binding energy that allows it to become itself, a little object that's self-contained, unless it can radiate that away, it gets destroyed. It goes back being the parts that it had. So in order for parts, and by which we're talking about individual atoms in forming molecules, individual molecules replicating themselves and being part of a living thing, that cannot happen unless there's something carrying away the positive entropy to satisfy the second law of thermodynamics. Now, I know I'm in my conversations with lots of people who are trying to get a handle on my work. Information is not something that's easy to understand. It's not like the stuff we get by reading a page or reading these words. It's a quantitative chemical and or physical quantity which we can measure by the amount of negative entropy that it includes once it's radiated away the positive entropy and become one of the information structures in the universe. Okay, over there in information theory, the work of Claude Shannon has shown that in order for a message to carry new information, there must have been alternative possibilities, because if there's only one possibility, then there's no new information. Now, I'll point out that there are a lot of philosophers of science and mathematical physicists who think that information might be, for them, a conserved quantity, like matter is conserved, energy is conserved. Some think information is conserved. I believe my work will eventually show they are wrong. I hope to publish work on this theory in the academic journals, which are the gold standard of increased knowledge. But as I say, I haven't had much success yet publishing papers in our journals like Physical Review or American Journal of Physics, but I hope to do so. In the meantime, I am writing all of this work up on my website, which is why I'm giving you this lecture, to point you back into my website for you to learn a lot more about these details. So in information theory, and here we're talking about the kind of information that we use to communicate, Shannon was an engineer at Bell Labs, which was the most important development entity that was creating our telephone networks. And he was studying how information be carried over the telephone lines in the presence of noise. So information is not conserved like matter and energy. And then I want to point out that information is not material. Let me come out to full screen here again for a moment. Information is made up of matter, but itself is not matter. It's neither matter nor energy. It is not conserved, although it needs matter for its temporary embodiment, like ideas in our minds, which, if we're lucky, may last our whole lifetime, and energy for its communication. I like to point out, like the lecture coming to you over the internet from my studio is being carried along by energy over the wires and wireless internet. Okay. Here I'm getting off into an area called philosophy of mind, because many philosophers of mind think that everything must be reducible to material, to physical matter, and then that matter must follow the laws of physics. I'm afraid all of these philosophers of mind and several of their colleagues are making a very big mistake if they think that they can argue that chemistry is reduced to physics, biology is reduced to chemistry, and the mind-brain is reduced to biology. these are the thoughts that are behind great philosophers today who are teaching their classes that we, human beings, the young students, are really machines of a sort. And what is happening in our lives is happening to us. It's not, they don't think that we are cells with a spirit, a soul, a character that somehow ideas, immaterial ideas, like Descartes, we discussed, thought we had a mind that was able to move the body in the so-called mind-body problem. And most modern philosophers call themselves determinists in the question of free will. They think determinism is compatible with free will, and it means it's not at all free. It's just that everything has been determined, and the future is already out there, and it's all just happening to us. In no way are we the authors of our lives. In no way are we responsible for what they're doing, although some are convicted hard determinists who think there is no such thing as moral responsibility. Galen Strawson, for example, Saul Smilansky, Derek Pereboom, others who I've written about and significantly quoted their work on my website, you can find that they believe that we are just objects which things are happening to, and our biology, reducible to chemistry, reducible to physics, our biology is giving us the illusion of thinking, the illusion of free will, the illusion of moral responsibility, the illusion of consciousness. They think that consciousness is not something that can be a property of matter alone, and therefore it's an epiphenomenon. It's something happening that isn't really there in the matter, but the matter has put itself together so as to make us think that we're conscious, that we're free, that we're responsible. I am sorry to say, but I think it's a scandal that this stuff, while it's worth thinking about and arguing about, is not what we should be teaching to young people. Because in that world, they're told creativity is not you. You're not actually being creative. And I am quite the opposite. I'm on the side of saying human beings are obviously creative. They're obviously bringing information into the world. 10,000 years ago, we hardly had any words for anything, or we were just developing the earliest notions of agriculture and so forth. And we've come to a situation where we're covered the earth with our works, our architecture. For better or for worse, we have changed the planet, and that is something that's our responsibility. So I don't care for those who think we can all be reduced. And I say here, I basically want to attack the notion of neurobiological reductionism and strictly determine what's called bottom-up causation, as if the atoms and molecules of our bodies are pushing out forces that go all the way up and make me think and wave my hand and all of that. At the same time, I have to defend, and I say this is possibly counterintuitive, I have to defend a sort of statistical downward causation, so that from the mind on down, free thoughts, mental events that are not predetermined, that's what I mean by free, they originated in our mind, are able to cause our willed actions, okay? So, my work is to describe it as a two-stage model of free will, which I basically argue can be traced back to the work of William James in the 19th century. And I'm going to say that I defend an emergent dualism in the sense that we now see how matter has come about and how it's formed the interesting things in the physical universe, the material universe of galaxies, stars, and planets. But there is a dualism here, and we can call it mind and matter, we can call it subject and object, we can call it idealism and materialism. Now, I should have lined those all up the same way and put I did, I guess, mind and subject and idealism as opposed to objects, matter, and materialism. Good. Let's see. We've got about 10 minutes in this talk, and I want to give you a kind of a radical way of looking at my triple of mind, matter, life, and mind. Let me go back to that for just a moment. and I'd like to connect it sort of to my green at Earth, red for life, blue for the mental, the intellectual, the spiritual, and the idea that we've associated through the ages. All the great thinkers describe us as subjects with a mind. We have a spirit aspect, what was criticized by these reductionists like Gilbert Ryle as a ghost in the machine, because a huge number of really educated people think we are just machines. I don't think we are machines, and I don't think our minds are computers. The idea of a computational brain is a very interesting exercise in which we can use the things we now know how to do with computers to help us try to understand what's actually happening in the brain at the level of neuroscience. I support all that research. I think we're going to learn a great deal, but I don't think that we are computers. We don't have logic gates. We don't have data buses with bits and bytes of information traveling around and located at certain addresses in the data store. The analogy of a CPU, which is cranking on all those bits, no, I don't think so. My model of the mind is simply a large set of neurons that have been connected together by being wired together, and they are wired together at all of our experiences because we have a recorder of our experiences, and it's set to play back whenever we get a new experience which goes into the wired brain and brings back past experiences that resemble the current experience in any way. And you perhaps have heard before, I'll say it many times, that what's recorded is not just our visual sense, our hearing sense and taste and so forth, but also our emotions that we are experiencing in the original experience, which is why when we have another experience later and it's similar to one in the past, which was intensely pleasurable, for example, or intensely painful, we get a reaction that's an automatic reaction that comes out that senses that we may be in trouble and whatever. And it's the past experiences that provide the context for us to add meaning to what is otherwise just information. Philosophy has a great deal of difficulty explaining what a specific kind of information means, because it's very contextual and subjective and personal and so forth. We'll work a lot more on that in the future. But I wanted to say about, and use this screen to do it, that when we talk about matter, and so we've got our green notion, we've got life, so it's our red sense of something in between, as if humanity is in between the material world and the ideal world. I like that symbolism. And then the mind. I want to sort of concisely and radically say that the first is from the beginning we have creation. And this is actually a rather radical and not exactly totally agreed upon notion, because many religions and many early philosophies and many cosmogonies or pictures of the way the world came about argue that it must have always been there. There's no way that, say, time started at a certain time and we come forward. Instead, we now, in cosmology and astrophysics, we argue for a creation. So I want to just say the first stage of the creation of the matter of the universe, we have plenty of evidence of a creation, but sadly, we don't have any evidence of any substantial kind of a creator. So basically, my first stage is creation without a creator. And I know that's a little radical for some, but it is what we now know, and I want you to know what we know so as to add it to the beliefs you have and argue those how they fit, whether they help you out. My goal is to teach the best knowledge. The best knowledge is an idea, what knowledge is most worth knowing. And remember, Richard Feynman told us the most important thing you could tell a future physicist if all information was lost and you had to start all over at the beginning, tell that future, write down a note and so they can read it maybe, but tell that future physicist, atoms, we're made of atoms. And that's my first stage. The universe is created, the matter creates structures all under the forces of physics. In the second stage, we have a picture in which life is a process that knows how to duplicate its information. And it almost seems as if it has a goal in doing so. Francois Jacob, the partner of Jacques Monod, the great biologist, argued that the goal of each cell, the purpose of a cell, is to divide itself and make two cells. It's a very simple notion, but clearly that's the driving process of life. It, of course, can't do that without the negative entropy stream from the sun, and we explain that. But it is something that biology does, is to duplicate itself and then take advantage of accidents that change the replication into something different. There we have the underlying sense of Darwinian evolution. Organisms are copying themselves, living things are copying themselves, mistakes are made, and some mistakes are failures and they don't get any farther, but others have a better reproductive success than the old one, and that is the potential for a new species. And from such simple beginnings, we have most wonderful things, most wonderful and most beautiful on the planet. And so to catch the notion that I have found and want to argue to you that we can see a creation, but no sign of a creator, we can also see evidence for evolution in our model of life as information duplicating under the control of information. So it's information itself that is instantiated in these simplest living things, and they are building and rebuilding as needed to expand the living things. It's got a drive almost. You could almost see the whole, anthropomorphize the whole thing as something is wanting to go forward and create more and more information. And I've tended to see that from time to time as almost a part of the universe that's doing good in the sense of replicating and preserving information. That becomes a personal goal of mine. The whole idea of information philosopher is to create resources, knowledge about information and how it's created, and put it out there in the world, in the web, where you can read it and others can read it. I don't really have much expectation that many people will follow my work in the near future, because in the cacophony of all the information in the world, it's hard for me to get heard. But I have put it on the web, hope to keep it there beyond when I'm gone. And I've produced books which have a natural lasting capability. Now I'm lecturing here, not so much expecting you to learn everything from my lecture, just my talk about it. Instead, I regard this as a pointer into my books, a pointer into my websites, where on pages, not only information philosopher, but my metaphysicist.com. And there I hope you will find, or some future people will find, something that will help them, resources. I've produced lots of copies of papers. I OCR them and get out the words, so you can copy and paste words out of journal articles that I put on my website and so forth. But now let me come down and make the succinct comment that whereas I have evidence for creation without a creator, what I've done here in the living world is to say I have evidence of evolution without a designer. Creation without a creator, evolution without a designer. The designer is fundamentally chance, and that upsets a lot of people, I know, but even Darwin himself didn't dare to say chance was involved because his wife thought chance was atheistical and would upset her and upset all her friends in the community. So he scrupulously avoided specific notion that the variations happen by chance. That would be claiming that God wouldn't know what changes were being made. And of course, in his day, the notion was that God sort of was making everything happen at some level, and that's why it turned out to be such a beautiful universe. but for Darwin it was just simple replication with accidental change, and therefore leading to the improvement of some species who could then out-reproduce the others. It wasn't an idea red in tooth and claw, killing everyone in order to get ahead, like our nation states these days, sometimes when they get in bad behavior. It was just a view that improved species could probably reproduce themselves faster and have a stronger life and a stronger existence. So let me get to mind. We haven't put a lot of time in on mind with just a couple minutes left, but basically I am arguing that the mind is immaterial. It's information that we can have in our brains, embodied there, so as to give us guidance and give us experiences that allow us to make decisions going forward in a reasonable free way, in my model of free will. But I want to argue that what we see as a mind, which has been for 100 or more years considered metaphysical and probably doesn't exist for many neuroscientists, it's just the mind is an illusion, like consciousness is an illusion. I see the mind as very much like what for centuries, if not millennia really, great thinkers have thought of as our spirit, as our soul, as our that ghost in the machine, which the mechanists and those who believe that we're reducible to the matter and the machinery called a ghost, a Geist in German. And I do think we have a soul. It is the seat of our character. It's a place where the traces of our good behavior and bad behavior are somehow in there for us to reflect on, okay? When we're conscious, when humans are conscious, they reflect on and compare the elements of the character that have formed in our lives, and we compare them to the external cultural community thoughts of good behavior and bad behavior, and that's what makes us responsible living things. So what I have to say at the end of the day is that although I have creation without a creator and evolution without a designer, I think we have a mind which is a spirit. It is a self, our character. It is that ghost. And at the end of the day, it is our soul. But whereas I have evidence of that I hope to convince you as a contribution to thinking about ourselves differently, I'm sorry to say that I have an immaterial mind, which is so like the notion, the ancient notion of that psyche, the suke, the breath of life, and so forth. It's immaterial mind, but without an immortal soul. Because the soul, I find, is the information stored in our bodies, in our brains, and in all of our cells. And the sad part of it is that whereas it is spirit, it is immaterial, it is the kind of thing that people accused of being panicky metaphysics, to think about such things, that mind, that soul, that spirit perishes when we perish. When we die, we lose all our information, unless we put it outside ourselves somewhere, like in my website, which in a way is a kind of minuscule maybe, but information immortality. The ideas are now outside me. So creation without a creator, evolution without a designer, and an immaterial mind, but without that immortal soul. Instead, a mortal soul, which is the seat of our character. It is our ghost in that machine, it's our spirit, it's ourselves. We are selves, we have a self, and that self is the summation of all of our experiences in our lifetime, all of our knowledge, and so forth. I guess that's all I have for today. Time is running out on us. Let me play my closing music here. Maybe bring us back to the page that we have here somewhere. Don't see it straight away. Here we go. So this is our lecture for today, and I thank you very much for being with us. Hope to see you next time on My Information Philosopher. lectures. Thank you very much.